kind of have a big list to look over. So I think the first thing I want to start with was destructive versus non-destructive test. Okay? What do they mean by destructive?
Pretty much going to destroy the piece you're testing.
Right. There is no salvaging this usually. Give me an example of a destructive test. What do you think is the most common destructive test?
The bend test.
Good, guided bend. Now, some of you guys were putting like it was only specific sizes. A bend test can be used on any size material, ultimately as long as it's a groove. Okay, so what they do is, this is your plate, and this is your groove, and you fill it up, right? All the way to the top. Nice, pretty weld. Then we cut off the backing, so there's no more backing. So we look at the penetration right into the backing plate. Then from here, an inch is cut off here, and an inch is cut off here. Okay, and then it's sliced into 3/8 of an inch piece. Okay, then what it'll look like is this. Okay, so then after that, we take it and we radius the edges before we bend it. Why? Why would I want to radius something?
It could cause cracking, right?
Good, right. So if you've ever tried even to bend a piece of paper, a really thick piece of paper, let me see if we can do it. But it comes almost like when we're trying to put it into a circle, right? What did we do? We kind of almost have to like rotate it a little bit and cut little notches in it so it makes that perfect circle, right? Well, that same thing will happen if we try to bend something that has a hard edge. So we radius the edge, okay? So this edge becomes radiused. And there's a couple of ways to do this. The most common is the plunger. So we have one out there, and it's like hooked to a thingamajigger like that. And it goes like this. So your piece is put in here and pushed down, so the piece is made into a U shape. Okay, now, we can turn it in different ways to get different results. I can make this the side face down here. So with side down, facing down, I'm doing a side bend, meaning my side is in tension. Now, I can go from the top, but the top, usually we can't do anything like with a root or a face bend unless it's 3/8 of an inch or less, because you can't do that with an inch plate trying to do that. So we can go from the top and put the root or the root in tension, or the other direction and put the face in tension. So we can see in different ways. Now, what does the guided bend test give us? What is the result for this guided bend test?
Tensile strength.
No.
To look for defects.
Okay, we're gonna look for defects. We're looking for soundness of weld. This is also used to qualify welders. Okay? Many tests will be done doing just this. Now, we bring up tensile. What is tensile strength first?
Being able to pull it apart with how much pressure.
It is to
where-
pull it, right?
Yeah, how much force?
Okay.
How much force it takes to pull it. So, now the machines are a lot more sophisticated, but it usually used to be like little manual one, little dial. And pretty much what they do is they can take just about any shape material, So we can do this with either a piece of material, a base metal. We can do that strictly weld metal, or like a filler metal, or we can have a weld in the middle. And we're gonna pull it until it breaks. And that's our ultimate tensile strength. There's other things like modulus of elasticity and plastic deformation that are looked at as well, but not quite as critically. So when we talk about the modulus of elasticity, it's how far can my material stretch before it hits the spinal point, this fracture point. And then when they talk about a material being plastic, it's how far I can go before it becomes deformed and it doesn't go back to its original shape. Okay? And there's a lot of calculation in here. You can use charts and so on and so forth for it, but that's the majority of what it is. Give me another destructive test.
The nick break test.
Nick break, okay, what does it do? How do we do it?
Hammer, right?
So what happens is that, okay, I don't have to use my fingers no more. Well, these are really good Expo erasers. All right, so a nick break. Usually we're going to use it for like a fillet. So let's say we have a T-joint like this, and our weld is right here. What we can do is we'll actually saw a little notch in it. And then pretty much get a screwdriver and bink, and shatter it open. What are we gonna look for?
Something defects.
Right, we're gonna look at the fusion, the defects. Now, a fillet weld break test is almost in that same way. We're taking that fillet weld, and what we're doing is if it's like this, we're smashing it together closed so we can see the penetration. But you can only do that if it's welded on one side. Okay, so that's one of the main destructive tests that they'll do for TIG welding. Okay, we can also do a shear test. And usually we're going to use that for spot welds. And we'll spot weld two pieces together and then we twist it. And they want the nugget, that big piece of weld metal, to stay in the bottom and the top be ripped out. And that's so it's supposed to be a successful shear test. Okay? What about non-destructive? What is non-destructive? Non-destructive, anybody?
The part can still be used. The part still can be functional. It doesn't get destroyed.
Okay, so we're not destroying our part. This also means that we can do it while it's in service. Okay? This means I can look at a building after it's been put up. Okay? What's the #1 non-destructive test?
Visual.
Visual, yes! Good. All right, why?
Pretty much the most convenient.
Okay, yeah, it's the most convenient. I can say, nope, that looks like that's porosity, right? Or that looks like a crack. But what if I can't see it?
X-ray.
I can use more than just X-ray. X-ray isn't as good as we think. Okay, well, let's start from the beginning. How about dye penetrant? Dye penetrant uses capillary action. So if you ever had like two pieces of glass with water in between them and you try to pull them apart, they kind of stick together, right? Or two glasses that have a little water. Okay, that's kind of capillary action. what happens is when we're using capillary action is that it kind of sucks in, and it sucks it in. So what happens is that, say we need to do a dye penetration on a plate. So we get the plate, and they clean it, okay? And then they put the penetrant in it, and it can be many different colors. And they have what's called dwell time. Dwell time is how long that dye penetrant needs to sit in that particular type of material and for how big or small of a flaw that we're looking for. Okay, and then after that time, they wipe it off or clean it off, and then it dries up, and then they put this powdery stuff on, and they call it developer. And what happens is that that powdery stuff sucks out anything that was in a cavity, and it shows up as a big indication. Usually, like, it looks like the plate is bleeding. It'll like suck up any type of little crack or crevice or hole that would be considered discontinuity. It's really kind of cool, okay? So that's the first one that we can do. We can do what's called magnetic particle. I kind of like this one. This one's kind of fun. So, I don't know if you guys remember the little toy with the man that had the little magnetic flakes, and you could make his mustache or his hair or whatever. Remember, like, it was like had a little thing. It was a little plate, and it was a little dude. He looked like he was bald, and then they had the magnetic filings, and you could put them all over the place.
Operation?
No. It was just.
He looks like a guy.
Yeah, it looks like that guy, but you could move the iron filings around to make a mustache or hair or whatever it was. Oh, well, $2 toy.
The ones where it's like a little board? Or
Yeah.
And they go like that and it erases?
No, like the little man. Kind of uses that same thing though. But what happens is that it uses those types of iron filings. Okay, and what it does is that we kind of dust it over, or it can even be suspended in an oil or a liquid, and it's put over the plate. And it's kind of gently blown off or wiped away. And then they put what's called a yoke. And it looks like this. And or a prod. And it looks, and there's a little handle on here, and there's a positive and a negative, and it's like an electromagnet. So, if in this area, if they put it over your plate, in this area where they had all of the iron filings, it will magnetize it in kind of the same way, like you ever break a magnet before? It makes a north and a south, and a north and a south, right? It works in that same way. So if I have a north and a south, right? North and a south, and I break it, I have another north and another south, right? And these kind of reject each other. Well, with that rejection, it makes the iron filings stand up and show that there's an indication that these iron filings got caught. Now, for dye penetrant, as well as magnetic particle, flaws must be open to the surface. Okay, so we can't see anything deep, deep, deep down. Okay, now of course, cracks are pretty obvious, but how do we see a crack that's interior? Well, there's a couple of ways that we can do that. So, Val, did they ever do ultrasound on your knee when they looked at it?
Yeah.
Okay, what did they put on your knee?
What they put on it?
Yeah, before they did the ultrasound.
Oh, that's the gel.
Some gel, right?
Okay, that gel's called a couplant.
Coupling?
Couplant. What it does, it actually allows the sound waves to actually enter into your body or enter into a material. And ultimately what happens is that the waves bounce off certain areas and keep going through others. Okay, so they call ultrasound, or UT, this is volumetric. Because we are able to be very precise in finding a flaw. If I have a plate, kind of funky looking plate today, and I have a flaw way down here, I can tell you it's 3 inches from this edge and 4 inches down. And I can tell you exactly where the flaw is. Okay, because of the waves that bounce off. So this wave's gonna come back and take a little bit longer, right? So let's say this takes 8 milliseconds. And we keep going, it's 8, it's 8, it's 8, and all of a sudden we get a 4. Well, that number changes, right? Well, now we know, uh-oh, something's bouncing back at us, right? And then we can go from different sides or different areas and go, oh, it's right here. And we can detect flaws much better. Now, what would be another non-destructive test? Do, new, 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 new. All right, X-ray, RT,
Oh, yes.
radiography. Here's the thing about radiography. It's not as good as you think. It's, in certain instances, it's very difficult to see if this is a flaw or a shadow, because of the way certain things have to be shot. Okay? And there are 2 ways. 1, gamma rays. 2, a radioactive source. So 1, we can turn on and off, another we cannot. So the one that we cannot, and it's kind of cool, they call it the pigtail, and they call it the pill. And it's literally a teeny, 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 tiny speck of nothing that's radioactive. And they encase it. Okay, so there's your little speck of cesium, whatever, okay? And then it gets encased again, and there's a window here. And this, to me it looks like a little old vacuum, and they're able to pull it back in, okay? So what happens is that this little pill gets driven into a little like metal house. And when they want to use it, they put the focal wherever they want it, and then they crank it all out to where it needs to go. And then they take their picture, so it can be anywhere from 15 minutes to 8 hours or 12 hours to take this picture with the source. And then once it's done, back in its house. And there's a considerable amount of math that's done with this, because we need to make sure that we're close enough to our source, that we're getting a correct picture, all sorts of things like that. So to me it's really interesting, and that's why I became a radiography interpreter. But it's nothing simple. You have to make sure that you're doing all the math correctly. This can also be volumetric. But if I say there's a flaw, and I see the flaw, I might not be able to tell you how deep it is. I can just tell you there's a flaw right there. So yes, I can see the whole plate, but in certain instances, I can only see little pieces of it. Oh, I forgot a really cool one for destructive test. Oh, it's my favorite. Sharpie vnotch. It's called the Sharpie vnotch. Hold on. Sharpie vnotch. I put a bunch of videos up on all of these types of tests because, me telling you does not give it justice. So, what the Sharpie vnotch does, the Sharpie vnotch is usually used for base metals and filler metals. And what they do is they machine, or they can even do it for weld metal. And they machine a piece, I think it's like a 1 by 2 inch piece. Okay, they machine it, and they have a little notch that's machined into this. Okay. And there's a little thing that sits against, kind of like this. And what happens is this big pendulum comes around and hits it. what they're doing is once this pendulum hits, it bounces, right? Once it bounces, it comes up and it shows our potential energy. When they start to make a calculation on that potential energy, and they can see how ductile or how brittle a piece of material is going to react. They can then make these plates super cold or super hot to see how certain materials are going to act in certain conditions. And it makes a big loud noise when it comes to a pencil. Okay? Kind of one of my favorites though, and they show how to do it. It's really kind of fun. Let me think about another one. Oh! Hardness testing. What's hardness testing? Idea?
Testing for hardness.
Bingo! So what it does is it actually tests, how brittle or soft a piece of material is. Now, let me think. There is Brunel, Rockwell, Knoop, and Vickers, as well as micro hardness testing. So everybody said, me, I'm making this test. The only difference between these tests is the different type of indenter. And it's kind of funny. Well, we're going to have to convert this from Brunel to Rockwell, and then Rockwell to Brunel, because we want, so there's nothing that's the same. One industry may want Rockwell, another industry may want Brunel, or whatever, Vickers or Knoop, and they're all about the same. So what they do is they have an indenter. Some of them are circular, some of them are diamond shaped, whatever it is, and they push it onto the material. And when we're talking about this, the indenture is probably like yay big. It's not a very big dent. And then they measure the size of the dent itself and do a calculation to see how hard or soft the material is. Okay, now, they can also do what's called micro hardness. So if I have a weld like this, they can take a bunch of little tests, some on my base metal, some on my heat affected zone, and some on my weld metal. Now why would we look at this?
Weld metal?
Well, all of it. So really what happens is we're looking at how hard or soft the base metal is, right? And then how hard or soft our weld is. And then the heat affected zone. Because ultimately when we're welding it, we're changing it, right? Because we're changing it, we want to make sure that we're not changing it to a point where we're affecting the mechanical properties. So when they do a micro hardness test, they can see the change and how much. And I believe it's 2 to 2.5 degrees of change, depending on what type of indenter you used, whether or not you're too far out of specification. Okay, so you can do that as well. Kind of thing. These ones, personally, they are destructive tests, but for some, they can be just ground out really quickly because these aren't very deep. So for some companies, they can just grind it flush and still be usable. Okay? And there's also eddy current. Eddy current is like an electromagnetic field that has as a gauge to kind of in the same way that the magnet works, and it's picking up where that spiking magnet is when we have a defect. But the thing is, an eddy current machine is
Monster.
it's a monster, and you have to be able to pass the material through the electromagnetic tube or through the coil itself in order to get something. So usually when they're using something like that, it's usually like in production of like pipe or tube that they want to make sure that doesn't have any defect in it. So then they pass it through as it's coming off the line. So then the guy, and then you see it, and it has like a little, like kind of like a little buzzer, meep, 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 and you can see the difference in the current. and they realized that with that differentiation in the current, you could find a defect. It's just not as used as much. There's one more. Wild guess it, guys. I want you to think about, hey, where's Adon? Our tank, our cylinder. What other test can we use? What would we use to test the cylinder?
Water?
Oh, you smart. What's it called?
Hydro.
Hydro. We do hydro testing. What does it do?
Check for leaks.
Good. And
Pressure.
pressure. Yes. So they're going to do this to the tanks between every 5 and 10 years to ensure that the tank is still solid enough to have gas in it. The only thing is if you evacuate it quite quickly, you can actually collapse it. So, and things like that have happened before, but they would rather have water go everywhere versus a tank blowing up. You know, kind of a big deal there. So, there are actually markings on the tank, right here on the band, that say, that are stamped in there the year that it was done, the month and the year. And there's like a star, and there's something else that says this was tested by this type of testing, da 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 da. But anytime you get a used tank, you need to make sure that it doesn't need some sort of testing. Because when you go to get it filled, they won't fill it. Because it's too old, it has to be recertified. So sometimes you guys can pick up really, really cheap tanks, you know, offer up whatever, guys selling them for 20 bucks. You go take it to the shop to get filled up and they say, no, we need to hire to test this. It'll be $300.
Wow.
You know, but it's good for 10 years. So it's not all bad, but those are some of the things that we have to look at and think about.
And what do they do, run it through a machine or?
So they actually, I've seen it done a couple of times. So pretty much what they do is they take this and they pretty much fill it with water until it be at a particular PSI and see how long it holds. If it holds, if it doesn't hold, if it springs the leak, if it blows any of the gaskets in it or any of the plugs on it, then hey.
That type of, yeah.
Well, because the bottom of your tank also has plugs. They have relief plugs. So they want to make sure that your relief plugs are good. They want to make sure that this is solid, that there's no cracks or injuries to it. Because yeah, we can drop a tank and it not crack or explode, but later down the line, it could have created a hairline crack that we just can't see.
Stay tuned for another part. Please like and subscribe.
Weld the world.